The United States military upgraded standard infantry units with advanced rifles firing modern ammunition, yet armored vehicle crews retain the stamped metal M3 submachine gun for a half-century, carrying this exact physical weapon from early Sherman tanks straight into modern Abrams configurations. Every single integrated weapon platform assumes total combat vehicle integrity. The main cannon, the coaxial gun, and the roof-mounted 50-caliber heavy machine gun rely entirely on continuous armor protection. These exterior engagement assets function exclusively under the condition that the crew survives and the engine block runs. That tactical advantage terminates the exact millisecond a kinetic armor-piercing round breaches the primary hull compartment. Armor penetration dictates immediate evacuation. Crews require interior stowage weapons. Standard rifles fail. Clearance is zero. 1957 arrived. The infantry upgraded their arsenals. Paratroopers transitioned. The Army formally purged the M3 grease gun. Armor branches refused the transition. The submachine gun remained. Not out of nostalgia. Stowage geometry dictated strict retention. The M48 patent required it. The M60 retained it. Turret volume severely restricts dimensional tolerances. Tankers fought with them in Korea. They deployed with them to Vietnam. Mid-70s at Fort Knox. 1st Battalion 67th Armored Drivers signed for the M3A1. The weapon matched Normandy specifications. 1991 arrived. Desert Storm commenced. 19th Engineer Battalion crews still carried them. 50 years of static equipment. Generations shared one firing mechanism. Caliber 45 ammunition. Low velocity. Maximum reliability. Then the M4 carbine finally achieved the required dimensional collapse, introducing 5.56mm ballistics into the exact same turret brackets. Armor thickness becomes irrelevant. The millisecond an armor-piercing round breaches the hull. During World War II, American crews operated the M4 Sherman. Early production models stored 75mm ammunition in unarmored sponsons directly above the tracks. Ordnance Department data showed fire erupted in 60 to 80% of all penetrations. Kinetic strikes ignited the propellant. The crew faced catastrophic failure. Engineers moved the ammunition to the hull floor. They surrounded the storage racks with 130 liters of liquid in wet stowage bins. The fire rate dropped. 15% still burned. A hull breach remained a terminal event. Crews had 15 to 30 seconds to evacuate. 5 men occupied the tank. The commander, gunner, and loader shared a single turret hatch on early models. They pushed through steel doors designed for combat seal, not emergency egress. Propellant cooked off inside the fighting compartment. Enemy infantry directed secondary fire at the immobilized vehicle. The War Department analyzed the casualty reports. In the summer of 1944, the Army distributed a tactical manual titled Combat Lessons. The directive contained a specific protocol for armored divisions. Tankers had to prepare for standard infantry operations. A destroyed vehicle forced the crew into open combat. They required a firearm compact enough to clear a narrow steel hatch under pressure. The weapon in their hands dictated their survival on the ground. The crew required tactical firepower. A standard sidearm proved insufficient. The M1911A1 held 7 rounds. Pistols failed them. Infantry units carried rifles. Wounded men faced crossfire. Ordnance supplied submachine guns. Sherman tanks housed single Thompsons. The design failed armored crews. It measured exactly 32 inches long. The weapon weight exceeded 10 pounds. Steel hatches restricted movement. Bulk trapped men. Extracting heavy weapons stalled escapes. Seconds dictated crew survival rates. Russell Spooner observed these crews. The armorer assessed European theaters. He defined M3 utility. Tankers raised the newly issued compact weapon. They cleared rims. The trigger released a wide defensive spray. Automatic fire suppressed hostile infantry. Bullets flooded the perimeter. Enemy soldiers sought cover. It bought time. Crews abandoned burning steel hulls. The weapon worked. Thompson replacement proved deliberate. Older firearm design suited trench warfare. Tank combat demanded extremely compact frames. That single cheap firearm existed solely to grant 5 trapped men a narrow window to exit a burning steel coffin. The battlefield outside the hull dictated the equipment inside. Late 1944 Sherman models received an inventory update. Planners allocated 5 M3 submachine guns per vehicle, 1 weapon for every man. 5 operators abandoning a burning medium tank required immediate firepower. The weapon parameters matched the spatial constraints. A folded M3 measured under 23 inches. The unloaded weight stayed below 8 pounds. Turret wall brackets held the steel frames. 2 mounts sat adjacent to the commander and loader escape points. Tank access rings prioritize ballistic integrity. They seal out shell fragments and concussive overpressure. They ignore ergonomic comfort. A standard Sherman commander hatch measured roughly 22 inches in diameter. The loader aperture offered identical clearance. A 32-inch Thompson submachine gun with a wooden stock catches on the metal rim. It delays the exit sequence. An immobile crew burns. The M3 bypassed this structural trap. A crewman grabbed the frame from the bulkhead bracket. He tucked the folded wire stock against his ribs in total darkness. The exit drop spanned 9 feet from the turret deck to the soil. The submachine gun cleared the hatch without friction. It guaranteed return fire during the first 10 seconds on the ground. The bureaucracy attempted to phase out this compact firearm, but the physical constraints of armored survival dictated an alternative outcome. 1957 brought the M14 rifle, utilizing a full-power cartridge with excessive recoil for confined spaces. The replacement weapon measured too long for emergency extraction. When the M16 entered standard service, its overall length still approached 40 inches due to the fixed stock. Its 5.56 mm ammunition targeted intermediate ranges rather than point-blank suppression during a vehicle evacuation. Neither standard infantry rifle physically aligned with the retention brackets welded to interior turret walls. By the Gulf War, these submachine guns remained bound to the M60 tank ledgers instead of individual soldiers. Armored units transitioning to newer platforms surrendered their hardware straight into storage alongside the retiring tanks. A 2008 publication confirmed the M4 carbine finally displacing the original firearm across select support formations. The metal project from 1942 outlasted its designated successors. It remained active for 66 years. Survival dictated mastering the first 10 seconds outside a burning hull. The .45 caliber cartridge defined the tactical logic. Bailout scenarios place threats close. Enemy infantry usually closed within 50 yards. The heavy subsonic round, firing a 230-grain projectile, delivered maximum energy transfer. It stopped targets reliably at these specific ranges. The M3 submachine gun provided zero utility for long-range engagements. Dismounted crews never fought at long range. Their objective required immediate withdrawal. The weapon absorbed the inherent filth of a combat vehicle. Turret compartments generate intense contamination. Hydraulic fluid, thick grease, carbon fouling, and ammunition residue coated every surface. Precision engineering jammed here. The loose tolerances and basic blowback mechanism of the M3 fired straight through the grime. The Armored Forces Board evaluated the initial prototype in 1942. Their approval established a standard. The weapon's retention after 1957 derived entirely from mechanical necessity. Successive generations of American tank crews faced identical constraints. They reached the exact conclusion their predecessors formed in Normandy. The receiver fit the designated steel brackets. The bracket held the M3A1 securely. Designers changed tanks, compartments remained tight. The Korean War began. Korea tested the M46, terrain, destroyed tracks. Then came the M48, armor stopped shrapnel. It failed against direct hits. Kinetic penetrators pierced hulls, tanks burned, forcing crews out. The enemy infantry waited outside. They needed short-range fire. The weapons stayed. Cold War planners mapped Europe. They marked the Fulda Gap. Soviet armor would cross here. American units held West Germany. The M3A1 remained aboard. A 1980s veteran remembered. He crewed an M106 mortar carrier. The unit fired them once annually. Parts showed wear. The mechanism still cycled properly. Soldiers carried them on guard duty. These receivers were decades old. Many were stamped in 1944. They outlived their original users. Vietnam introduced a new environment. Helicopter crews adopted exact logic. Cockpit space dictated weapon size. Rotors failed, and pilots crashed. Enemy forces closed in. Survival required immediate defense. The process to replace this compact weapon revealed its own distinct bureaucratic failure. The procurement cycle rarely tolerates obsolete hardware, upgrading every component from composite armor to communication arrays. Fire control systems evolved constantly, but the grease gun remained. In 1991, American tank crews entered Kuwait aboard the M1 Abrams. It was the most lethal platform on the battlefield. It featured advanced thermal optics. It carried a 120mm smoothbore gun. Crews destroyed Iraqi armor at distances exceeding enemy visibility. Everything regarding this deployment represented peak engineering, except the crew compartment defense tool. That weapon was designed in 1942. Procurement boards lack sentimentality. Hardware survives 50-year cycles strictly because nothing else completes the exact mission better. The M3A1 stayed aboard for a precise mechanical reason. The tactical parameters established in 1944 still dictated crew survival. A crew abandoning a burning hull requires specific dimensions. The frame must slide through a hatch constraint. It must deploy instantly. The mechanism must cycle without complex input during physiological panic. It must deliver enough kinetic transfer to halt approaching infantry. No modern replacement fulfilled these spatial requirements simultaneously. The 50-year tenure was not an oversight. The inventory retained it deliberately. The deliberate retention of the weapon bypassed standard procurement logic. The military bureaucracy consistently attempted to equip armored crews with standard infantry-issue rifles. An infantryman required range and sustained accuracy to engage targets at distances exceeding 300 yards in open terrain. A tank crew member faced an entirely different ballistic reality when emerging from a disabled vehicle. Their engagement distances were measured in feet, initiated from a standing start while exiting a confined metal hatch. Standard service rifles proved excessively long, unnecessarily heavy, and fundamentally misaligned with the spatial constraints of a ruined armored hull. The engineers behind the M3 submachine gun prioritized rapid production and low manufacturing costs over mechanical sophistication. They inadvertently created a platform that solved a specialized spatial problem that procurement boards had largely ignored. The evaluation criteria for standard weapons focused on effective range, theoretical accuracy, and mechanical complexity. The grease gun bypassed those metrics by functioning reliably during the worst 10 seconds of a crew member's deployment. The weapon remained in the active armored inventory until the conclusion of the Persian Gulf War in 1991. The eventual replacement officially entered service in 1994. The military discarded new submachine gun designs and adopted the M4 carbine. The new platform featured a collapsible stock that finally compressed a standard rifle into the exact spatial footprint required for armored vehicle egress. It provided superior ammunition capacity and integrated optical mounting rails without compromising the dimensional requirements of the vehicle interior. Internal mechanical components did not fail under combat pressure. The retirement occurred because structural engineering advancements finally produced a standard-issue weapon that occupied the identical minimal physical volume. The half-century deployment cycle concluded. A modern platform finally fit inside the exact same dimensions.